Welcome to our podcast for our quiz over Chapter 4, and it's going to take place November 20th. That's next Tuesday. Reminder here, if you are going to be absent on that day, or even if you're going to be going on next week, it's a must that you take the quiz beforehand. And this is more of a benefit for you because waiting until after, having all that time off, you're going to typically do worse than you would if you take it here before. All the resources are up on my big campus, practice quiz, discussion board, study guides have been passed out, so you have everything you need. So you need to see Mr. Cora or myself, Mr. Windmiller, to let us know if you're going to be gone. If you're not sure, please check with your parents. Okay, let's start here. Charles's law. This is something that we took a look at the end of last week. Temperature of a gas at constant pressure is increased. Its volume also increases. So as you take a look here in the diagram, you can see we have negative 65 degrees Celsius and 250 degrees Celsius. So as temperature of a gas at constant pressure, so the same amount of force pushing down here is the same. Its volume increases as its temperature increases. So as temperature raises, this increases. The amount of volume, the amount of space that they're taking up. And as you can see here within this picture, the particles in the cold here are much closer than what the warm. So they do move around more. That's Charles's. The next one that we took a look at was Boyle's law. When the pressure of a gas increases at a constant temperature, so both containers in the picture have the same temperature. When we increase the pressure, so they have in this picture basically the weights here, okay? So we've got P1 here on the left and P equals 2 on the right. So pressure is increased on the right, and you can see the temperature is the same. So we're not changing the temperature, we're just changing the pressure, and that pushes down. So the volume decreases, it's less. And if you push harder, temperature stays the same. If you push harder, and again, we did this in class and we took a look at the app on the iPad, that the volume decreases. So the amount of space that it's taking up is less. Okay, occurs when the surface particles of a solid gain enough energy that they form a gas. That's sublimation. And we've got a picture of dry ice here where it's moving to form a gas. Condensation, change in state from a gas to a liquid. Cold glass, warm moist air hits, and condensation forms. Where does that condensation come from? The air around the glass. It is not coming from inside the glass, coming from the air around the glass. We did this obviously in our investigation for my glass. Okay, evaporization or vaporization, our book uses both, the change in state from a liquid to a gas. And as you can see here, we have evaporation taking place on this pond or lake. Viscosity. I always thought this is a great picture for viscosity. Liquid's resistance to flowing. And you can see as we move from the one on the right here, as we get virtually no dripping out, this is a little, this is almost like I would say kind of a syrup type thing. It's a little thicker to the point where it is coming out somewhat, to here finally probably something similar to water where it's running out very quickly. Okay, which state of matter changes volume easiest? Gas. How are the particles in a solid arranged? As you can see in the picture, they are packed very closely together. And we took a look at this and read in our book, and they do vibrate. So even though a solid per se is not moving from what we can see, those particles do vibrate back and forth. Particles arranged in a liquid. Here you can see they're packed together, but they move around freely. And these lines that you see here in the picture are showing movement. And biggest thing to understand with liquid is that they are packed together. They are closer together, but they do move around freely. So as you look at the pictures and the differences here, the solids are going to be together, very closely packed together. Liquids are going to be a little far apart, but you can see when you compare in this picture here, there are less molecules in this picture, but more than what you're going to see in gas. You do need to be able to tell the difference between these. There'll be pictures on the quiz. You need to be able to tell the difference between these and understand and give evidence as to what they are. So they're packed together, but they move around freely, and that's what those marks are. Finally, here we have our gas, and you can see the amount of space between them is a lot more. So there are less shown in the picture, still have the marks showing movement. These spread apart, filling all available space. How does heat affect pressure? This goes along with our laws at the beginning. Heat increases the speed of the gas particles, which increases the pressure. The speed is increased because the energy is increased. When we have more energy, more speed, so as they move around, they're going to increase the pressure. What happens to the volume when pressure is increased? When pressure increases, volume decreases. So basically think, if we've got a container here and we've got a handle and you're going to push down on that handle, this is going to move down to a point maybe here where you have all those molecules packed up in here. And that volume, the amount of space that it now takes up, is quite a bit less. Okay, practice questions. Here's your list. You can pause this and copy these down. Again, these are good to start to work on the application part. Whenever we start working on the application where we're really preparing for the actual quiz, we need to put our study guide aside. So let's try and do these questions and the practice quiz on My Big Campus as much as possible without the study guide, because you're not going to have that study guide on the day that you take the quiz. Okay, finally, once again, November 20th, 2012, that's next Tuesday. Please make sure that you talk to Mr. Cora or myself if you're going to be gone on November 20th. And this would be a planned absence. Obviously, if you're sick, we'll give you time when we come back. But if it's a family vacation, you need to check your handbook. And in the quote-unquote rules of family vacations, all tests and quizzes should be taken prior to your absence. Study well.